Hello, everybody, and thank you for attending the Digital Twin Consortium webinar entitled Optimizing Asset Management Performance with Simulation Digital Twins. My name is Meg Duncan, and I am the Marketing Director for Digital Twin Consortium. Before I introduce our speakers today, I'd like to give you a very brief overview of our member-driven organization. As the authority in Digital Twin, our members drive adoption, improve interoperability, accelerate the market, and demonstrate the value of digital twins through working group collaboration. Our steering committee consists of representatives from our founding and contributing members, Dell, GE Digital, Johnson Controls, Microsoft, and Northrop Grumman. Our global membership comprises technology providers, government agencies, academia, researchers, and end users of digital twins, and we continue to expand our reach with our liaison relationships and regional branch organizers around the world. Within the Digital Twin Consortium, our members have established several major working groups focusing on digital twins across industries and in academia and research, architecture, engineering, construction and operations, agriculture, food and beverage, and so on. If you are interested in joining us in our mission to advance digital twin technology, adoption, and best practices, please visit our website for more about the benefits of membership. You'll find the link in the attachments to this webinar, along with other relevant documents, including a PDF download of the presentation deck. There is, you'll find that at the attachments tab. There's a Q&A at the end, and you can ask a question at any time during the presentation, and we'll try to get to as many as we can at the end. It is now my great pleasure to introduce our speakers today. We will be joined by Michel Morvan, who is the co-founder and executive chairman from Digital Twin Consortium member Cosmo, a digital twin simulation platform provider, and he will be talking about asset management using digital twins with Joël Serre, who is the asset management and industrial maintenance expert at Airbus. Joël is a proven expert and leader in asset management and has spent his career in the asset life cycle, where he has foreseen the power of data to simulate asset behaviors. And we will begin first with Joël. Thank you very much for being here.
Thank you, Meg. Thank you, everyone. Good afternoon, and thank you for joining. Let me switch to the first slide. The first slide is showing the major target of Airbus, that when we benchmark around industrial asset management, we saw a benchmark around 20% saving around the TOTEX reduction. And we were a little bit having a view on that and saying, is it feasible or not? And what are the challenges to do that? And clearly, the first challenge is align the stakeholder around a constraint to discuss and take decision on cost and CapEx, OpEx that you have to spend on your asset in your plant. And here you've got around the table different jobs like the manufacturing engineer, the CapEx manager, where they are struggling to align. And clearly, for example, the manufacturing engineer will struggle to deploy new technology, as in the same time, you will have the maintenance manager who want to optimize this cost and to stay with knowledge that you have already in place. And that is the first big challenge on that, to align on that contradictory constraint that we face in the asset management approach. And it's where after I will tell you and explain how the digital twin is a way forward to support that decision making. The second big challenge we have faced just behind that is clearly the complex processes, method, and tools we've got in our industry, but also in big companies where optimizing our spend is facing decision-making with very often linked to expertise, knowledge, and also, I will say, feelings. And the topic of that is today, more or less, and this is also part of the benchmark we have done in the community of asset managers, the decisions are taken mainly 80% on on the expertise, on the feelings, on the view of the needs of the stakeholders in the shop floor, or on the fashion area. And only 20% are taken related to data. And here, the view of the decision making I want to push or try to put in place is clearly to have a decision making on data with 80% of the approach related to that, and keeping also the approach related to the expertise, because you cannot take a fully decision related to data. You need also to have strategy view, performance approach. And this is clearly the view that the digital twin will support us in the decision making for the future, improving the performance, the resilience, and including also the sustainability. Alors, how is the approach and our journey in Airbus side on the subject? The slide is split on two parts. The left side is the principle of asset management that we have built in Airbus. You find in the middle the same table with people around discussing on the decision they have to take, clearly saying what is the life cycle execution we have to do, clearly maintaining, operating, acquiring, and dispose the assets. That decision making have to be aligned with the strategy of the company, and that decision making related to the famous norm ISO 55000 is clearly linked to performance, link, and cost. And now could we be sure when we take that kind of decision that we are aligned with our company strategic objective or with our top company objective, like we say in Airbus, TCO? This is also an opportunity for digital twins to make the link on that, meaning that having a view on what could be the behavioral of the line, of the station, or simply the machine sometime, and that the decision we are taking won't be a challenge in the year coming, saying we take something wrong or we haven't taken the wrong decision at that time because we haven't get the opportunity to see what should be the reality of the lines. On the right side of the slide, this is the role of the asset manager we have defined, and it was one of our first step in the journey, saying clearly what is the role of an asset manager in Airbus. We saw it as an orchestra maestro, I will say, but with a wide understanding of the industrial system. And this is clearly a profile of a job that is able to provide a comprehensive overview on the decision we have to take. Very often around the table we will have specialists, people knowing perfectly their subject, and here the role of that job is clearly to ensure vertical alignment, but also ensure horizontal alignment between the different stakeholders you have around the assets. And in our complex line, this is not easy sometimes to get an overview with clear, with understandable by everybody, and particularly also by sometimes top managers, CapEx team. And that view have to be provided across the life cycle of the industrial system or of the industrial assets. That is showing that the decision we are taking today, again, is not providing or bad performance or high cost in the future or big risk that we cannot tackle or where we struggle on. Alors that's what I was saying also, that role is breaking the silo. Why is it so important to break the silo also in a company like us? Is that very often we've got a decision coming from the executive committee, coming across top company objective, and that's not very easy sometimes to implement that level of decision or to, let's say, not transform, but I will say apply the decision in the shop floor. And the role of the asset manager in Airbus is clearly seen as a link, a belt who will make that role, because when you are in a factory, in a day-to-day activity, clearly you have no time to think about that. You saw sometimes decision, we will go to robotics, for example, or we will try to improve our drilling processes. And in this case, this is very difficult to the people in the shop floor to make that link. And this is, again, the role of the asset manager to make that link, vertically speaking. And horizontally speaking, this is with the counterpart you've got around the table that are clearly the manufacturer engineering who is buying the line and the assets. And he will also show to them that some decision that they are taking or they will take could have affect the performance of the line or also the cost of the line. Voilà, that one was clearly an explanation on that. Here I will switch to more developing the digital twin for the asset management approach. The first part was more what is asset management and how we see it in Airbus. Alors I will go to the left side of the slide, seeing that we have today a lot of data everywhere in our area, particularly implicit or explicit data. And until now, we are clearly managing or forecasting the future by mirroring the past. And that mirroring of the past is clearly the way of the maintenance engineering is working today, and saying, okay, I have a machine or whatever, an industrial system, and I will imagine that the industrial system will have the same behavioral tomorrow that you have in the past. And we know that in reality, this is not what is happening. And here we got a great opportunity to define what are the fault degradation of the machine with the explicit data and with the data that we get. We can define that diagram and that view. And here with the approach of the digital twin, forecasting with different scenarios, how the behavioral of the machine or the line will be, and clearly making some run on that, forecasting better the future, and will be more aligned on that. As you saw on the bottom of the slide, this is not a simple journey. This is a journey with lasting years and years, because you saw that our target is to improve our operational excellence around 20, 30 years, and with the same opportunity saying, let's see if we can reach 20% of saving. But I will show you that in a more example after, in a concrete example after. And I'll let the end to Michel for more explanation on digital twin.
Thank you very much, Joel. And so, well, thank you for what you just shared, because before we go into the examples and the use case, Airbus use case, and also others that I will share with you guys, there were very important things that were shared now by Joel. The first one is, wow, it's very complex, right? Yeah, so many things to take into account. That's the first thing. The second, I mean, I'm not going to go into detail, but the second one is what you need is visibility. You need to know what will be the impact of your decision with all these things happening together. And the last one is, you cannot just rely to the past. You cannot just look back years. You have to be able to look forward. So that's what we are going to explain, and that will be the role of digital twin and what we call simulation digital twins. So here, yes, I'm going to share with you rapidly what we mean by 360-degree simulation digital twin. So to the left, you have the real world, right? That's your system. That's your machines. That's the people working on it. That's it. And you're going to do a twin. You're going to twin it. You're going to replicate it based, of course, on the data you have on the system. What you see here is what we call a real-time replica of the system. Here, what you see is kind of a 3D representation. In our case, 3D is not very important. What you have much more than 3 dimensions. You have hundreds of variables, hundreds of things to take into account. So you do a replica. That's what we do with simulation digital twin, and you have the ability to simulate. And simulation of the system, you have all the rules, all the interactions, and you can see into the future. And that's what simulation digital twin is. You can add uncertainties, you can do a lot of what if scenarios and see different effects of decisions you can make. And of course, at the end of the day, what you can do is choose the best future you want. And once you have it, because you have done a lot of them, you can go back and control and make your decision and have, you know, the best possible decision. So if you go back to what happens, that was general, what happens in asset management with that? Well, you're going to take into account in your twin, look to the left from top to bottom, corporate financing and industrial strategy. How does it work? Then site financing objectives, because of course you have to take that into account, site maintenance objectives, and site production objectives. And you have to have all that together. And thanks to the twin, while it seems completely unmanageable, well, you can put that together, and then you can test different, for example, asset replacement and do simulations. And you can replicate the dynamic evolution of asset aging and all the cascading effects. And thanks to that, the complexity that you have to the left is included in the twin. And because you can simulate the twin, then you have visibility on multiple futures. And you can do that taking into account a lot of dimensions, which is why we say 360-degree simulation. So if you look at it, I mean, digital twin classically, what do you have? Here you have two axes. One that is the horizontal one to the left, it's what allows you to be aware and react. Middle, anticipate, and the third one to control and automate. And on the vertical one, you have connected asset and connected ecosystem, the system itself. So traditionally, the twin is used to describe what is. You can, design information, IoT, enterprise, and contextual data. That's the classical thing. You create a twin, you know where you stand, and you know the state of your system. Then, in other domains, you have twins where you can do physical simulation, you can do data, you can do machine learning. So you're doing that for one machine, for example. But what you're interested in is to have the whole system and to be able to predict what is next. And more than that, to prescribe what is the best course of action. That's what we call orchestration, scenario management, hybrid AI experiments, robustness. I mean, you can do a lot of things. But the important thing is what we provide is at Cosmotech is all these two bricks, how to predict, to simulate, and to prescribe to find the best possible solution for your problem. So maybe, Joël, now you can go and share the exact results you obtained.
Alors, thank you, Michel. Let's go to the shop floor, I will say, to show you what we have done on a use case with clearly an industrial one with a riveting machine that was on Nantes site. Nantes is a city in France where we got a factory. We are producing part of the plane. And for the one who are not familiar with our industry, this is riveting machine. It is the part of the side shell of the aircraft that are attached with rivet. We have made the studies on that machine because the machine are costing several million each. They are also they are strategic machine because they can clearly stop the production in Airbus. Clearly, they are producing the part for different aircrafts. And also, there was a big discussion around the replacement and the I will say asset replacement strategy. I will start to use that word because of the end of life of that asset. And I will show you what are the habits that we have around the end of life of that asset. Alors that the study we have done, it's for 6 machines. They are between 20 and 30 years old. And you've got an MTTR on that machine with close to 2 to 7 hours. That means that there is some discrepancies in the data, in the technical one, that are not allowing to take a simple decision, because here you saw that the MTTR is clearly different between one or the other machine. And this is not, it couldn't be the single KPI showing you, okay, you have to replace that one. And even if you want to replace, do you need to replace it? Do you need to refurbish it? What do you need to do on that machine? Could I keep it for the next year without putting in danger the production line? Alors here you've got the simulation we have done with the tool of Cosmo test, sorry. And the objective was clearly to define and to optimize the investment decision. And what we have done with that tool is we have balanced the CapEx cost, the OpEx cost, of the recurring cost, and also what are the cost of downtime. That means that clearly the cost of non-production, the cost you are losing related to the bad performance of the machine. Well, and the discussion on that 6 machine was to say, okay, what should we do? Do we need to replace them or not? Do we need to put in place 6 new machines and to crash the previous 6 one? And now we can handle that. And you can easily also imagine that it's not an easy decision, because in the same time you are doing that project, you have also to continue to produce. And that means, back to the first presentation, you've got a lot of stakeholders around the table for that kind of decision. And each of them have got the right argument, the right decision, let's say, to push in their view what they have to do. Alors for doing that, we have used the software of Cosmo Tech. And we have first define and calibrate a model. And to define that, we have split the machine in different components and in different functionalities. That's what you have on the top, the 90 components simulated. And then after, we have calibrated that. And for calibrating that, we are using the data we've got in our system, in our CMMS system, from the past, using that data as a reference to create the model, but also using the data to say to the model, okay, it's happened that in the past, there is a breakdown with a stoppage of whatever the time, and what is the model saying, and is the model able to reply the same situation? And this is clearly a thing we have seen, and with you accurate your model with different data that you grab from your CMMS, and you've got after a kind of accuracy who is coming, and after you decide when you stop doing that kind of calibration. And we stop in our case saying that for the technical data we were at 93% of performance of the model. That means that not so far from technical availability of an industrial system. And we've got a more difficult situation for the cost and the money we are spending on our machine. And here we stop more or less the calibration of the model when we were at 85% of result forecasting the model. Well, when you have do that, and that's a job who seems to be very hard, but in reality, it's depending on the data you've got in your CMMS, and clearly also the people around the table that are showing you the data, because you need to be sure and to trust your data. You operate and simulate the breakdown. Now we got on the top the figures, and it's 120,000 simulation of failure that you can imagine that the model is running that and showing after you the bar graph that you see. And that are showing that the different scenarios you've got the time on each scenario is showing, I will replace the machine more or less as usual at 10 years. This is the first scenario. Everybody saying every 10 years you have to do something on the machine. And you saw the cost, the global cost. And then after, the last one is, I will replace the machine at 35 years old, when is 35 years old. And the middle, you saw clearly the benefit of the decision that you can take. And here in our case, we've got machines who've got different ages. And in this case, the decision was wrong because they were saying, we will refurbish first one of them. And that was the one who was able to last in production more time than they were imagining. And when we do the meeting and showing the result of that, they say, yes, no problem, we can switch and use another one, refurbish the bad one. and use that also as a forecast for the year coming and saying, okay, let's do that one first, then we buy a new one. And then after we know also that new technology will come. And in this case, we can do that. And you've got around the table people who are looking to that and saying, wow, that's incredible because we are aligning people on that. Clearly, you got the CapEx guy who is smiling and saying, okay, that's fine. I have an overview on what CapEx I have to put in my file. You've got the maintenance engineering who is happy saying, now I understand clearly the picture and what I should do. And you've got the production guy who is also having a confidence in what we are doing on this line. Voilà. After, in the middle of the bar graph, you saw that there is sometimes figures who are very close. And this is clearly the margin that you have to take decision. That one I will change it at when he's 20 years old. That one I will wait 25. And that one, what is the risk I am taken or I will take if I wait 30 years old. Voilà. Here, this is clearly the result of the power of a digital twin affected to an asset management approach with an asset refurbishment strategy. Alors, let me switch to the conclusion. The conclusion was clearly for me on that approach that we save 50% of the total budget. It was not 20 as we've got in our benchmark, but not so far. As a conclusion, you've got a highly sensitive data who are the cost, and I was surprised to that. I was thinking more at the beginning that it is the technical with having problem, or we will have problem on technical data, and it was not the case. After, they've got a good ability that we have done to perform sensitivity analysis to refine the outcome. That means that you can push the model and saying, for example, if I stop my maintenance, what will happen? If I push my production to what level of that, what will happen? If there is a risk that I have raised, I don't know, whatever, could be a risk for environmental topic, for example, what should the impact? How can I reorganize that? And here, this is a great optimization that we can do for the future. And to finish, there is a real interest of the stakeholder around the table that I have shown at the beginning. They were clearly saying, and I will use the phrase of the CapEx guy, and the guy was saying, clearly, Joel, I will use your study and I will follow your study without any doubt on the result. I give back the stage to Michel for other example.
Thank you very much, Joel, for this, very concrete example of using simulation digital twin for making decisions in this context. So I'm just going to go through other use cases, much less in detail than what you just did. So we have just seen optimal replacement age for the asset fleet. I'm going to talk about 2 or 3 others. There could be many different ones. So the first one will be bottlenecks in an investment strategy. Then we will refine it for, is CapEx strategy in line with CO2 emissions objective? And another completely different one on asset failure risk on a much shorter time scale. So let's go to the first one. So assume you're managing, you're industrial asset manager, and the CFO comes and say, hey, I want you to decrease CapEx budget from 32 million euros to 20 million. That's typically a CFO request, right? So how can you manage that? So current situation, CapEx, 4 million every 4 years. And the request, and you know what a request it is when it comes from the CFO, is now we want to be 4 million euros every 8 years. And the question is, how can you answer to that to say, is it a good idea or a bad idea? Well, what you can do is you can use the digital twin simulation and look, okay, what will happen to my system, to my OPEX, CAPEX, and downtime cost over the years, the coming years. So in the future, you're going to the data if you apply the CFO request. And you can see that the overall cost here will be 121. This is the current situation, 121.2 million for the overall cost. So what is requested by the CFO? Well, you look at it, you do the same simulation, you take exactly the twin that we discussed before and that Joel discussed before, and then you go back to the CFO and you say, oh, I'm sorry. Well, if we do what you ask, then the overall cost will be 123 million. And so this is a good argument, for a CFO, when you can come and say, well, look, we can do what you want, but the impact will not be very good. So then you can see because the aging will have increased bottlenecks because of the problem, and the overall cost will be higher. So here's you have to find a compromise with the CFO, and then you can do a lot of what if simulation to determine minimal investment to mitigate the bottleneck risk. And when you do that, then you can see that 4 million every 6 years is probably the best situation, and you can look at it, look at the future value and say, hey, this one could be the best solution. So that's the kind of things you can do with the tool. And now you can say, okay, I have this CapEx strategy. Is it in line with CO2 emission objective of the company, at the global level? Well, that's good, because in the tool, you can take into account also the CO2 emissions. So you can take this new strategy, 4 million CapEx every 6 years, and you can look specifically on the graphs that are going to describe the CO2 emission, and you can see that this curve is decreasing, but maybe it's not enough if you compare to what you wanted to do. And then if you want to have some specific objectives, then the best is to check and to say, well, the best, if you want to mitigate that, because you can see into the future, you can find the best way to do it. And thanks to the digital twin and thanks to the simulation, you can say, well, the best possible way to do it is 4 million over every 5 years. So then you can see, you look at the simulation, you test it, and you can see that it's good. That's the goal you want to reach, and that the total cost is not too high. So you can decide that this is what you want for the company. And the last one I'm going to talk about, so this one was more or less, the same at a long time scale, but let's look at a very small, short time scale. So the problem is the following. You have a factory, you're doing real-time monitoring, and you want to do prescriptive mitigation plans. So assume you have one production line, you have 10 machines in this production line. So we are at a very short time, and we're going to look at it in that way. Every minute you have the machine performance that is captured, and the line performance based on the machine performance that is captured in real time in your twin. The line performance is projected for the next 8 hours. So what does it mean? It means that you have some interface like this one. So to the left, you have the real-time data, and it's the overall equipment effectiveness per machine. You have 9 machines here, and you can see to the left that everything was fine with the OEE, but the yellow one is dropping, right? So that's the real time. So to the left is the past. What is just in the middle is the real time. And what you have to the right, the curve, the graphic, is what will be the volume produced over the 8 coming hours. So you can see that it's going to work well, even if there is this drop on the yellow machine. The yellow machine is decreasing its performance. But what you can see is that in 8 hours, this machine performance decrease will have a very big impact. And what you can see is the total amount of volume produced will be below your target, your alert threshold, that is 38.32 thousand. So you have a problem, and you know it 8 hours ahead, thanks to the simulation connected to real time. And then, of course, once you have that, and I'm not going to elaborate too much, well, you can say, what can I do? And what can you do? And you have different curves here showing the impact of what you can do. You can say, well, I don't do anything. Or you can say, okay, I'm going to send a team and to repair the machine now. Or you can say, what is the best moment to repair the machine, for example? And you can test all these scenarios and find the one that is okay for you among all the possible scenarios and actions that you can manage. So once again, I'm not going to enter into detail. You have seen here that you can do things at long time scale, short time scale, and globally it's scalable. We have customers French electricity transmission network who works with 1 million assets, all the equipment of the electric transmission network. You have 1 million assets, 30 million planned operation per scenarios, and 30 to 100 year time frame with daily use to find the best decision on the network. And you have another who is a global European manufacturer. It's only 90 asset components integrated in the digital twin, 10,000 planned operation per scenario, from 1 to 40 years time frame. It depends, and it can be also at the day or at the hour, and you have this scalability. So the major results in various industries transforming asset management, I mean, that's kind of a summary. It's increasing 10% by 10% of operational efficiency, 10% decrease in total expenditure for the same with the same performance. You reduce the operational conflicts by 12%, and you increase, in some cases, in the regulated industry, the one I talked about before, the electric transmission network, bigger budget allocation. We are talking about, hundreds of millions of euros, so it can be impactful. Just for you to know, 360-degree simulation digital twins, which allow to visualize the future and the data from the future, it has a lot of application domains for asset-intensive industry, not only asset management, but also, for example, transport and logistic optimization. We have just taken one example. You have a lot of factories, you have a port, you have final destinations. You want to optimize these things. You have all these factories, you're in the middle, you have thousands of equipments to ship. You have tight schedule to respect, of course, and different size of vessels and routes. And of course, as you know, booming shipment cost. How can you manage that? You use 360-degree simulation digital twins to run a lot of scenarios, to test the different options that you can do, and identify the best routing options to reduce booming shipment cost. So you can do a lot of different things, and hopefully we will with these simulation digital twins. Thank you for your attention. We are open to the questions.
Thank you very much, Michel and Joël. That was a fascinating presentation, and we do have some really great questions for you. I'm just going to take the slides down for a moment, if that's okay. The first question, I think, would be directed to you, Joël, which is, what kind of feedback did you get from the Airbus end users on this approach?
To be fully transparent with you, we were a little bit afraid when we present the solution, and particularly when we discuss with the technical guys in the plant and saying we will support you in the decision making by a methodology, because it's not a question of tool, it's a question of methodology to try to clarify and to make the decision more on data than more on feelings. And the first things I have said before also is that the people are saying, okay, we won't take the full decision on data, and we're saying no worries, we will take the advice of the expert behind. And then at the end of the discussion, and at the end when we saw and we see the result of the study, they were very, very positive. And I can tell you that today we are doing other study in other plant, one in Spain that is started today, because people are saying to me, that we spend a lot of time in meetings, spend a lot of time in exchanging and trying to align each other. And here there is a clear things that is coming, showing result, fact that we can discuss. Nothing is perfect, but that we can discuss, but it's aligning people. That's it. The feedback of the shop floor was very positive.
Excellent. Thank you very much. I think the next question would be for Michel, but possibly for both of you. Are you doing first principles models as well as machine learning?
It's a very good question. Maybe I can start answering. The Cosmotech 360-degree simulation digital twin platform is a platform that allows, and that has been created for, that allows any kind of modeling and simulation. So it can be, a lot of different kind of simulation. The platform is made to integrate them and to couple them one with the other, sometimes very different ones. you can put together discrete event system simulation, and you can couple it with multi-agent simulation, and you can couple it with dynamical systems. I mean, whatever you want, and the platform is made for that. So it really depends on the situation and on the tool. Here we have a tool that is what we call a prepackaged simulation digital twin that is called Asset. And for Asset, we use some different kind of simulation type and modeling type, but it can change for one solution to another.
Thank you. Did you have anything to add, Joel?
No. I think clearly the proposal is to make a simulation, and that we can adapt the simulation on what we want to do, and it's clear what we've done on the machine. And I remember the first discussion with your team, Michel, when we were saying we want to simulate machines, clearly splitting the machine in functionalities, and it was possible. There is a clear ability of the system to be modified. And then after, there is a clear things that perhaps you don't say that it's very impressive for the customer like us, is that you can modify the parameter and play with the simulation you have done.
Yeah, and if I can add one thing, of course, we also use machine learning. So if in some cases, for example, for modeling some machines and the asset health of the machine, depending on sensors, in some cases, nobody knows how it works, and you have to learn it from data. And this is something that the platform can do, but it really depends on the situation.
Thank you very much. We also have a question that I think would be interesting to hear from both perspectives. Can you talk about the journey of getting the data together to build a digital twin?
Oh, you want to start, Joel? Or you...
I will start that one because this is the first reaction, let's say, that everybody have when you go in the shop floor, even when you discuss with a maintenance engineer, for example, because for us, the asset manager is part of the job of the maintenance engineer and is foreseen for the way forward. And the clear discussion, the people are saying, we don't have the data, they are not in good quality. And here we clearly discover that you have to spend time and to clarify what are the data you need and what are the trustness you have in the data, because that's the important thing. But it's not hours and hours. I think we do it, I don't remember exactly, but in 4 weeks, 6 weeks, something like that, discussing with the maintenance engineer, showing the data that we got in our system, and after clarifying that. That means that don't be afraid of that kind of situation. I was afraid also at the beginning, saying that's not possible. In reality, that's clearly feasible.
And if I can, that's very important. And thanks for sharing the experience. And one reason why people sometimes are very, very, scared by that is because when the systems are based only on machine learning, when you do only machine learning, which is not our case, we can do machine learning, but it's not machine learning. You need a lot of data from the past. So, and usually you don't have a lot of data from the past. But here, because we are doing modeling and simulation, because we are modeling the processes, because we are modeling, the interaction between things, we need only small data. And because we have that, we can also study the sensitivity of I would say, the uncertainty we can have on some data. And that's what you mentioned, Joel. You said at the moment you were surprised because the very sensitive data was not the one you expected. It was mainly sensitivity on the cost rather than some technical aspects. And this is something the simulation can allow you doing, which is finding the good quality of data for the problem you want to solve, and with the technique you use.
Thank you very much. And it looks like we're running out of time, and we have so many good questions. I'm hoping that we can get some of these answers to you offline. We'll send them to our speakers and try to get you the answers. We have time for one final question. And Michel or Joel, what is the best way to get started with developing a simulation digital twin in my organization, is the question.
Maybe I can say one word about it, and you can complete, Joel. Well, the idea is start from the problem you want to solve. So the idea is not to do the universal simulation digital twin of all your business or whatever. start from a specific problem, I mean, as it was described by Joël in this case, and take a small perimeter and start creating the twin or using the existing twin, whatever, of this perimeter. The perimeter has to be small enough so that you can really manage it fast. We are doing and providing value to customers in 12 weeks. So it has to be small. We cannot do that for all Airbus, for example, in one shot. But the idea is that it has to be complex enough so that you can really create value by using it. So start small, and then you can grow.
Did you have anything to add,
Yeah.
Joël?
I fully align with what you are saying, Michel. Start small, go to a need, go clearly to a need that you got in your plant or in your area of work. In my case, it was clearly a need coming from the CapEx team, for example, who are saying how I can forecast the behavioral of the machine, how I can be sure that in 2 or 3 years that machine will be at 95% of availability. Start small I show you a small perimeter, 6 machines, with a big value for the company somewhere, and you saw that in this case. And that your proof of concept will be recognized by your top management and by the people around. Voilà, that's only my advice, and this is not an impossible job. You can do it, sure.
I want to thank you. I want to thank our presenters for this great presentation, so much information, and thank you for your time, both of you. And I want to thank our attendees to this webinar for joining us today. We have a lot of attachments to the webinar. You can visit our website. You can download a PDF of this presentation. There's an invitation to an upcoming Digital Twin Consortium event taking place in February, which is called The Value of Digital Twins from Concept to Reality. It's a virtual event. We invite you to join us. And we also have in the attachments a link to this strategic roadmap for asset management, a Gartner report that you can download courtesy of Cosmo Tech if you are interested in learning more. So once again, I thank you very much for attending. Joël, Michel, do you have any final words of wisdom?
Thank you very much. And it's a great journey. And I hope Joël will say the same.
Yes, have a good journey. Thank you also. Thank you, Michel, for sharing that adventure.
Thank you very much.
Thank you very much. Have a good rest of your day.